All right. Well, let's get started looking at these chapter problems. We are looking at concentration for the first, looks like the first half of this. So let's get started. We remember that concentration, concentration is molarity. And molarity is moles divided by liters, right? If I cover up molarity, moles divided by liters. So I'm given 0.175 grams of ammonium acetate. Well, if I know grams, we need to know in our head that grams, we need to get to moles. So that's going to be the first thing I need to get. I need to get to moles. And it's dissolved in water to make 45 milliliters of solution. Again, I need liters. So let's divide this by 1,000. This would give us 0.045 liters. What's the molarity? Well, let's take our 0.175 grams of ammonium acetate. You're going to look at your polyatomic ion sheet. Remember, ammonium is NH4. That's a +1. Acetate is -1, and that's C2H3O2. So we can have one ammonium and one acetate. Okay, we need to find the molar mass. I'm going to help you out here and tell you that the molar mass is 77.08 grams for 1 mole of ammonium acetate. So let's plug that into our calculator here. 0.175 divided by 77.08. And I get 0.00227. That's moles. And I'm going to divide that by 0.045 liters because the definition of molarity is moles per liter. All right, so we're going to divide this by 0.045. And we want, let's see here, 2 significant figures for our final answer. So I'm going to say 0.050 would be my molarity for number 1. All right, let's look at number 2. We have an aqueous solution is 0.120 little m. That stands for molality of glucose. What are the mole fractions of each of the components? Okay, so remember, molality, little m, is moles per kilogram. Okay, so this 0.120 little m stands for 0.120 moles of glucose per 1 kilogram of water. Right? It's an aqueous solution. So if it's in solution, that means it's in water. And this tells me that this little m is moles per kilogram. So that's how many moles of glucose per kilogram. And we can just assume that that's 1 per kilogram of water. Okay, so the mole fractions of each of the components. In order to do mole fractions, I need to know the part of glucose of moles divided by the whole, which means I need moles of the glucose and the water. So I got the moles of glucose. I got to figure out how many moles of water this is. So let's get from kilograms of water to moles of water. Well, if I have 1 kilogram, that means I have 1,000 grams of water. And if I know grams, I can get to moles, right? Grams to moles of water. What's the molar mass of water? 18.02 grams of water for 1 mole of water. So let's do 1,000 divided by 18.02. And I get 55.49 moles of water. Okay, so now I know moles of water. I know moles of glucose. Now we can do our mole fractions. So we're going to do our part of glucose divided by the whole, which I need to add these two together. So let's do the mole fraction for glucose first, 0.120 mole of glucose divided by, and I'm going to add 0.120 plus 55.49. What does that give me? 55.61. That's our total. So 0.120 divided by 55.61. So my mole fraction for glucose will be 0.00, how many sig figs? 3,216. And my mole fraction for water, so this is for glucose. And for water, we'll take our part of water, the 55.49 mole of water divided by the total. That's the glucose and the water, so which was 55.61. And let's plug that in. 55.49 divided by 55.61. And we said 3 sig figs, 0.998. There is our two mole fractions. Let's look at number 3. It wants us to dissolve 62.1 grams of ethylene glycol, which is 1 mole of ethylene glycol, in 250 grams of water. Calculate the mole fraction, the molality, and the weight percent of glycol. Well, let's do this part first, the mole fraction. Remember, mole fraction is part divided by whole, and we need to be in moles for both of them. So we're told that this many grams of ethylene glycol is 1 mole. We have 250 grams of water. Let's get that to moles of water. So 250 grams of H2O. And we already figured out the molar mass of H2O. So we've got 18.02 grams for 1 mole of that. And that should give us 13.87 moles of water. Okay, so let's do our mole fraction. For the ethylene glycol, we'll just call that, let's see, we'll just spell it out. So we're going to do the part of ethylene glycol, which is 1 mole, over our total moles, 13.87 plus 1. 1 came from this, 13.87 from water. So a total of 14.87 moles total. So our mole fraction is going to be 1 divided by 14.87. So our mole fraction for the ethylene glycol is 0.0672. And then we can do the mole fraction for water. So again, we do the part of water, the 13.87 moles of water, divided by the total, 14.87. That'll give us 0.933. So our mole fractions are done. Now let's look at molality. Remember, little m molality is how many moles of solute per kilograms of solution. Okay, so if I know my solute, we were told there was 1 mole of solute. Divided by kilograms of solution. Well, we were told that we had 250 grams Let's get grams to kilograms. We just need to divide by 1,000. So that would be 0.250 kilograms. So 1 divided by 0.250 should give me 4, a molality of 4, and that's moles per kilogram. Okay, and then we have one more piece, the weight percent of glycol. Okay, so weight percent, weight. We measure weight in grams. So we were told that we have 62.1 grams of glycol, and we're going to divide that, again, to get percent, we need our part divided by our whole. So we have 62.1 grams plus 250 grams. So that's a total of 312.1 grams total. So our part divided by the whole, that'll give us our weight percent. 62.1 divided by 312.1. And then we times that by 100. So 19.9% would be our weight percent of glycol. Let's look at number 4 here. We want to know the molarity of a solution made by diluting. Oh, as soon as I see the word diluting, I remember that M1V1 equals M2V2, or you might have learned it as C1V1 equals C2V2. So the concentration times the volume of the initial is equal, or the molarity is the same as the concentration, is equal to the concentration times the volume of the diluted solution. So we're diluting 3.5 liters of 0.2 molar solution. So this is our volume 1 and our concentration 1. And we're diluting it to a volume of 5 liters. So that's our volume 2. We want to know what is the molarity of that solution that's being made. Cool, so let's plug in what we know. M1 is 0.2 molar. V1, 3.5 liters, is equal to M2 is question mark, and V2 is 5 liters. So we can just find M2 by dividing both sides by 5. That'll cancel that out. So let's do 0.2 times 3.5. 0.2 times 3.5. And then divide that answer by 5. And we should get 0.14 and 3 sig figs, so 1.140 molar. Let's look at number 5. We're told that a solution is 20% sulfuric acid by mass and has a density of 1.2 grams per milliliter. Before we get any further, I'm going to stop there and dissect this. 20%. So what that's telling me is that if I had 100 grams of solution, that means that 20 grams of sulfuric acid, which is H2SO4, is present. That's what 20% means, right? 20 divided by 100, and then times that, right? If I did 20 divided by 100, and then times that by 100, I get 20%. So we can use these numbers to get us started. Now, it says it has a density of 1.2 grams per milliliter. So we know that density is mass divided by volume. Well, I know that the mass of the solution is 100 grams. And I know the density of the solution is 1.2 grams per milliliter. So let's solve for the volume of the solution. And we'll just do 100 grams to find volume as mass divided by density. So 100 grams divided by 1.2 grams per milliliter We should get 83.3 milliliters. All right, so that's a good starting point for us. We know how much solution we have. But let's keep going, see what else we need to actually calculate. Calculate the concentration of the sulfuric acid in units of molarity and molality. Well, molarity, remember, is moles per liter. Molality is moles per kilogram. Okay. Let's figure out what we need to know first. We need to know how many moles of sulfuric acid per liters of solution. Well, luckily we know milliliters, and we can divide that by 1,000. So we know we have 0.0833 of solution. Now let's figure out moles of sulfuric acid. We have 20 grams of H2SO4. I'm going to help you out with the molar mass here. Molar mass is 98.079 grams for 1 mole of sulfuric acid. And that will give me 0.204 moles of H2SO4. Okay, this will let me get concentration. So I can take my moles of acid divided by liters of the whole solution. 0.204 divided by 0.0833. They get a concentration of 2.45 molar. Okay, molality. Remember, molality is moles of solute over kilograms of solvent. So not the whole solution. All right, so we know our moles of solute we just found was 0.204 moles of H2SO4. Now, kilograms of solvent. I don't know how much solvent I had. I know the total volume of the whole solution, but if I go back to here, if I know that I had 100 grams of solution and 20 grams was H2SO4, I can just subtract these two. 100 grams minus 20 grams, that was my acid. So I have 80 grams of my solvent. Now let's go from grams to kilograms. We'll divide this by 1,000, which would be 0.08 kilograms of the solvent. So 0.204 divided by 0.08 should give me a molality of 2.55 moles per kilogram. Moving on to number 6. We want to know volume in liters. We're given concentration of a solution, and we're given grams of the solute that's dissolved. So since I'm given concentration, molarity, and I want to find liters, I need to know moles, I need to know molarity. So I know molarity, I need to find moles. I'm given grams. 65 grams of magnesium phosphate. Well, magnesium is +2. Phosphate is PO4 with a -3 charge. So this compound would be Mg3PO42. We need to find the molar mass. We need to add up 3 magnesiums, 2 phosphorus, and 8 oxygens. That should give us a molar mass of 262.855 grams per 1 mole. And I'm going to plug and chug here, 24728 moles. So I know moles now, and I know molarity. So to find volume in liters, it's moles divided by molarity. 0.24728 moles divided by 0.095 m. And remember, m is moles per liter, and that's why the moles will cancel out. Okay, that gives us a volume of, and we want 2 sig figs, 2.6 liters. Number 7, what volume of this concentration of hydrogen fluoride should be diluted? Oh, I say diluted. That means M1V1 equals M2V2 to form 1 liter of that concentration acid. So I know the concentration that I'm starting with is 3.75. I want to find that volume, and I know concentration 2 is 1.25. We can see that it's a lower concentration. 1.25 is lower than 3.75. And I want to make 1.75 liters of it. So we'll divide both sides by 3.75 to get V1. And we should get 0.583 liters because we want 3 significant figures. Number 8, we're given, it says, what mass of aluminum sulfate octahydrate is needed to form 750 milliliters, so that's our volume, of, we're given a concentration, molarity. Well, if I know concentration and volume, what can I find? If I know these two, I can multiply them together to get moles. And if I know moles, I can get to mass. So let's do that. First, I need this to be in liters, so I'm going to divide by 1,000. So I'm going to say that our moles is equal to 0.465 times 0.750 liters. And that gives me 0.34875. Now, in order to go from moles to grams of aluminum sulfate octahydrate, I need to write this compound out so I can get the correct molar mass. So aluminum is +3. Sulfate, look at your polyatomic, is SO4 with a -2 charge. So that would be Al2 SO4 3. Octahydrate means 8 waters. So why don't you pause the video here, find that molar mass, and let's see if we match. I got 486.292. That would be 2 aluminums, 3 sulfurs, 12 oxygens, 16 H's, and then 8 more O's. So we're going to take our moles to grams, and we should get, with 3 significant figures, 1,560 grams of the aluminum sulfate octahydrate. All right, so let's look at number 9. Here we're given a chemical reaction. It looks to be balanced, but I always double check. 2 Ks, 2 Ks, 2 chlorines, 2 chlorines, Pb, 2 NO3s. Yep. Okay. What mass of lead nitrate? So we want to get to grams of PbNO3 is required to react with 1.25 liters of this concentration of KCl. So we need to somehow go from here to there, which means we need to have mole to mole ratios. All right. Well, we're given liters and we're given concentrations. So with that, we can find moles of KCl, can't we? Hopefully you're getting used to this. So if I want to find moles covered up, it's molarity times liters. So let's do 1.25 liters times 0.550. That's capital M. And we should get 0.34, nope, wrong one, 0.69375. Okay, that gives us moles of KCl. We want to get to mass of something else. So let's do our mole to mole ratio. There's 2 moles of KCl for every 1 mole of lead nitrate. All right, that gives me, so take that answer and divide it by 2, and we would get 0.346875 moles of PbNO3, 2. And we know if we have moles, we can go to grams just by finding the molar mass. The molar mass of lead nitrate is 331.2. So multiply across and divide by 1, and finished with 3 significant figures, should give us 115 grams of PbNO3, 2. All right, let's look at the last one on this page, number 10. We're given another equation, and we want to get volume in liters. We know the concentration of AgClO4, and we know grams of something different here. Silver chromate. Okay, first things first, let's make sure that we have a balanced equation. I have 2 Ags on the left, on the right, so I need 2 Ags on the left. And I have 2 NAs on the left here, so I need 2 on the right. And I believe everything else is balanced. Okay, so the first thing that I see is I have grams. And we can't do anything with grams. It always has to be in moles. So let's get our 160 grams of Ag2CrO4. Let's get that into moles. So the molar mass of silver chromate is 331.73 grams for 1 mole of silver chromate. And where are we trying to go to? We're trying to get to silver chlorate. Okay, so we're going from here to there. Let's just keep going with this. We're going to say 1 mole of Ag2CrO4 for every 2 moles of AgClO4. So let's multiply across, divide going down. So we now know moles of the silver chlorate. We know concentration of the silver chlorate. So if I know moles and I know concentration, we can find volume, right? That's just plunging it into molarity, moles, liters. Find volume, it's moles divided by molarity. There's our moles. Let's divide it by the molarity. 0.600, capital M. So 0.6946 divided by 0.6. And we want to end with 3 significant figures. 1.61 liters of AgClO4.